Welcome to today's video. In this video, I'm going to continue looking at square roots and cube roots. And in today's video, I'm going to look at cube roots. In this video, I'm going to describe what cube roots are. I'm going to also show how you write the cube root of a number. Then later on, I'm going to demonstrate how you can find cube roots of given numbers. So watch this video up to the end. Let me start by defining what a cube root is. So a cube root of a number is a number you multiply by itself and then multiply the result by the original number to get that number. Okay, so a cube root is the number you multiply by itself and then multiply the results by the original number to get that number. So in other words, we are saying a cube root of a number is the number you multiply by itself 3 times to get that number. Okay, so in this scenario, I'm talking about when you have got a number, then you multiply a certain number to get that number, then the number you have multiplied 3 times is a cube root. What I'm trying to say is this. For instance, I'm multiplying 3 by 3 in this instance to get 27. I'm multiplying 3 times to get 27. Therefore, we can say 3 is the cube root of 27. So I've multiplied 3 by 3, which has given me 9, which is the result. Then the result I multiplied by the result, which is 9, I multiplied by 3, the original number, which gives me that number, which is 27. Okay, so that is a cube root. So a cube root is a number you multiply 3 times by itself in order to get a cube. Okay, then therefore we can write 3 as a cube root of 27 like this. So this is how you write a cube root of a number. So in this example, I'm using 27 and 3. So the cube root of 3 is 27. You will write a small 3 there, then a square root, then 27. That is 3, the cube root of 27, which is 3. That's how we write the cube root, like the way I've written in red there. Okay, now let me show you how you find cube roots of. Okay, let's find cube roots of the following numbers. So the instructions for the 2 questions is evaluate the following numbers: cube root of 64 and 2 cube root of 216. So the first question is cube root of 64, and the second question is cube root of 216. So let's start with the first question, which is cube root of 64. So how do we find the cube root of 64? So what I'm going to do is I'm going to rewrite this question on the right side of the equal sign, like the way I've written it in green. Then the next thing I'm going to do is I'm going to express 64 as a product of prime numbers or prime factors. I'm going to express 64 as a product of prime factors. So the first question I'm going to ask myself is, what number or what is the smallest prime factor that can go into 64? So the smallest prime factor that can go into 64 is 2. So I'm going to write 2 down there. 2 can go into 64, and 2 is a prime factor. So 2 into 64, it will go 32 times. So I'm going to write 2 multiplied by 32. So when you multiply 2 by 32, will give you 64. That means we haven't lost the value of 64. Okay. Then I'm going to rewrite 2 again here. I've already found one prime factor. So now let's look at 32. What is the smallest prime factor that can go into 32? What is the smallest prime factor of 32? The smallest prime factor of 32 is 2. So I'm going to say 2 multiplied by 2. So how many times can 2 go into 32? It will go 16 times. So I'm going to multiply by 16 times. So when you multiply 2 by 2 by 16, it will give you 64. Okay? But in this expression, 16 is not a prime factor. So we need to find another prime factor that can go into 16. Okay? So I'm going to write 2 multiplied by 2 because these two numbers, 2 and 2, are prime factors. So we have managed to find 2 prime factors that can help us to make it 64. So what smallest prime factor can go into 16? That is, smallest prime factor is 2. So 2 can go into 16. So 2 is the prime factor of 16. So I'm going to multiply by 2. Then I'm going to ask myself, how many times can 2 go into 16? It will go 8 times. So I'm going to multiply by 8. So when you multiply 2 by 2 by 2 by 8, you get 64 as an answer. Okay, then I'm going to rewrite these 3 2's I found already. Then I'm going to ask myself, what is the smallest prime factor of 8? The smallest prime factor of 8 is 2. So I'm going to write times 2. How many times can 2 go into 8? It will go 4 times. So times 4. So when you multiply 2 by 2 by 2 by 2 by 4, you get 64. Okay? So the next thing I'm going to do is I'm going to write the 4 prime factors I've found. As you know, 4 is not a prime number, so which means I need to convert 4 into prime numbers. So which is going to be, I'm going to write the 4's, the 4 2's I've found. Then I'm going to ask myself, what prime number can go into 4 without leaving a remainder? That is 2. 2 is a prime factor of 4. So I'm going to write 2. And how many times can 2 go into 4? It will go 2 times. Then I'm going to multiply also by 2. Now, when you look at this expression I've made, the one which is at the bottom, you will see that it is made of prime numbers, which are 6 2's. So we have come up with an expression of prime numbers which can give us a product of 64. When you multiply these 6 2's, they will give you the answer, which is 64. 2 by 2 will give you 4. 4 by 2 will give you 8. 8 by 2 will give you 16. 16 by 2 will give you 32. 32 by 2 will give you 64. Okay. Once you have done this, then we have expressed 64 as a product of prime numbers. The next thing you're going to do is we are going to put them in 3 groups. Since we are finding cube roots, we're going to put them in 3 groups. So we are going to put the first 2's in one group, then the first 2 2's, they will be in one group, then the middle 2 2's will be in the second group, and the last 2 2's will be in a third group. So it will be like this. Okay, I've paired them in 3 groups, and these groups are identical, as well as they will give you the product which is the same. Okay, so when we start, we multiply 2 by 2 will give us 4. So I'm going to write 4 there. Then the group in the middle, 2 by 2 will give you 4. So we'll say times 4. Then the last one, 2 by 2 will give us 4. So it will be times 4. So as you can see, these are the products of the 3 groups. So as you can see, the product is the same. We have gotten 4. Okay, so what we're going to do is we're going to write 1 4 from these 3 4's, and that is the cube root of 64. So we'll pick one of the 4's among these 3 4's and write it down. That is the cube root of 64. So what we're going to do is we're going to get rid of the cube root sign and write 4 alone without the cube root sign. So we're going to write 4 like this, and this 4 is the cube root of 64. So we can say therefore 4 is the cube root of 64. Okay, now we go to question 2. Question 2, they want us to find the cube root of 216. So I'm going to write 216 like that. Then I'm going to ask myself, what is the smallest prime factor of 216? Or can 2 go into 216? We are saying yes, so 2 will be used because 2 is the smallest prime factor or prime number of the prime numbers. So we are going to write 2. Okay, then how many times can 2 go into 216? It will go 108 times. Okay, then we are going to write 2 times 108. Then we are going to write 2, then multiplied by 2, which is, while we are multiplying by 2, we have noted that in 180, 2 can go there without giving a remainder. So I'm going to use 2 to divide 108, which will give us 54. So when you multiply 2 by 2 by 54, will give you 216. Okay, so what I'm going to do, I'm going to write the first 2 prime numbers we have found, which are 2 2s. Okay, then I'm going to ask myself, what is the smallest prime number that can go into 54? 2 can go, so I'm going to use 2, which I'm going to write times 2. Then 2 into 54, it will go 27 times. Okay, so when you multiply 2 by 2 by 2 by 27, it will give you 216. Then we say we're going to write these 3 2's. Then we say, what is the smallest prime factor that can go into 27? And the smallest prime factor that can go into 27 is 3. So I'm going to say times 3. Then 3 into 27, it will go 9 times. So I'm going to say times 9. Okay, I've found 4 prime numbers that can help us to express 216 as a product of prime numbers. So I'm going to write these 4 prime factors which I've found already. Then I'm going to ask myself to say, what is the smallest prime number that can go into 9? We are saying 3. So I'm going to say times 3. Then 3 into 9, it will go 3 times. Then I'm going to multiply by 3. Then, as you can see now here, the expression here down has only prime factors that can give us 216. So I've expressed 216 as a product of prime factors. Okay, so what I'm going to do now is I'm going to group these numbers into 3 identical groups. So these 3 identical groups should give us the same product, as well as they should have the same numbers. Okay, so what I'm going to do is I'm going to write I'm going to pick 1 2 and 1 3, put them in one group, and again I'll get another 1 2 and 1 3, put them in one group. So the groups will be formed by numbers which are 2 and 3, which will be multiplied 2 by 3. So we are going to say like that, the way I've put it. So each group is formed by 2 numbers which are 2 and 3, which are multiplied 2 by 3, 2 by 3, 2 by 3. Okay, so in each group we have got 2 by 3. The groups are identical, and when you multiply them, they will give you the same product. So let's try to check if the product will be the same. So 2 by 3 will give us 6 times 2 by 3 will give us 6. 2 by 3 will give us 6 times 6. So as you can see, we have come up with 3 6. Okay, so now since we've come up with 3 6 as products, the products are the same. That means we grouped the prime factors of 216 correctly. Then what we're going to do is we are going to pick 1 6 from the 3 6, and then we're going to write it down. We're going to get rid of the cube root sign, and we're just going to write 6 alone. Okay, once we have done that, that means now that is the cube root of 216. So the cube root of 216 is 6. Therefore, we can say 6 is the cube root of 216. Okay, so basically this is how you find the cube root of a given number. If you have got questions, you can ask in the comment section. Otherwise, thank you so much for watching. It has been Easy Learning Z mathematics. The future is bright. See you in the next video, and God bless you.